Welcome to another video from explainingcomputers.com. This time it's the second and final part in the short series in which I'm making a desktop PC less noisy. In the last episode we fitted a new Noctua CPU cooler, and this time we're following that up by fitting this Corsair RMx series power supply. Very nice piece of the kit. This should make the PC more energy efficient as well as a bit quieter. And we're also going to be fitting, if I can find them down here, there they are, bring them into frame. Also we're going to be fitting these new Noctua case fans. So let's go and get started. Right, here we are back inside the PC we're making less noisy, where in the first part of the series we fitted this Noctua NH-U9S CPU cooler, which reduced the noise made by this PC at idle from 42 dB to 35 dB, or from this to this. And by the end of the last episode it was very clear that most of the sound coming from the PC was now coming from this, from the power supply, so let's remove it. And to start that process we need to remove any cable ties that are constraining any power cables. So I'll do that. There we are, and I'm so glad I don't fit those cable ties where you can't get them off. I love using the Velcro ones. And the next thing we need to do is to remove the 24-pin ATX power connector from the motherboard, or in other words this down here. So I'll get that out hopefully in a manner you can see just about what's going on. I'm bound to obscure things getting out some of these connectors with my fingers, but there we are. Oh yeah, we got the power connector out like that. And on a modern motherboard there's also an additional 12-volt ATX power connector, which we can see down here. You might be able to see this is an 8-pin socket, which is what most modern motherboards have, and currently it's fed by a 4-pin 12-volt connector. And that is fine providing your computer doesn't use a massive amount of power. Older power supplies don't necessarily have the 8-pin 12-volt connector. And do not worry, if you've got a 4-pin connector, it'll only go in one way if you have to use the 8-pin socket. So I'll try and get that out again without obscuring things too much. I can't, can I? I'll just pull it out anyway. There we are, it has gone. And the next thing we need to do is to remove the power from our drives. And in this computer there are actually 3 drives mounted. There's a hard drive down here, an SSD here, and a DVD drive up here. Although the hard drive isn't currently connected to power, this is a test rig. I only connect that in when needed. This is not part of our experiments here to make a very quiet computer. This has not been spinning in any of the tests and won't be spinning. It's just there because it's easier to leave it there in case I need it in the future. So I will take the power lead out of the back of the DVD, which I can't possibly show you. That has come out. There we are. And we'll also remove the power connector from the SSD down here, like that. So now anything connected to the power supply in this PC has been disconnected, although I'd note that in some PCs you'd also have to disconnect cables from, for example, a graphics card that might be fitted down here, or maybe another type of expansion card, maybe a USB 3 card which has got a power connector in. And there might in some PCs be some case fans connected directly to the power supply rather than as here to the motherboard. But assuming that isn't the case, the power supply is now free to remove, so we will grab Mr. Screwdriver and go round the back where we can remove the 4 screws that hold in the power supply. There we go, and it should therefore now be possible to take the power supply out of the computer like that. Being careful of the motherboard and anything else it might hit in the way out, but there we are, it's coming out. The cables are free like that, and we can now put it down over here and go in search of its replacement. Right, here we have our lovely Corsair RM550x power supply, which cost me £69.99, which is about $92. As we can see, it's got an 80+ gold rating, and 80+ means that the power supply will be at least 80% efficient at all loads, with the additional gold rank indicating the power supply will be at least 87% efficient at all loads. Or in other words, for every 100 watts it draws from the wall socket, this power supply will deliver at least 87 watts to power the computer, with no more than 13 watts being wasted as heat. And the less heat generated, the slower cooling fans have to turn, and the less noisy everything will be. Therefore, if you want a quiet computer, it's a good idea to get a power supply that's as efficient as possible. When choosing a power supply, it's also important to select one with an appropriate wattage, and there are lots of online calculators available to help you work out the maximum power that your PC requires. Here, this 550 watt model, which is the lowest rated in the RMx range, will be perfectly sufficient because the PC we're working on will theoretically need no more than 200 watts absolute maximum, and I've no plans to add a high power graphics card. Earlier, I also measured that with the old power supply, the PC was consuming no more than 20 watts at idle and no more than 74 watts in my rendering load test. And of course, these meter measurements are of the power being drawn by the old power supply, not the output it's providing to the computer. So the figures should fall a little when we fit this new PSU with its 80+ gold rating. So let's open this thing up. Let's bring in Stanley the knife and cut through the cellophane initially. Very exciting. Oh, Stanley's being noisy. Here we are, new power supply. Rustle, rustle and all that. And hopefully now it just opens up. Oh, it does. It's easy. There we are. Even I can get inside here. And we've got a power cable. We've got lots and lots of cables here. And we've got the power supply itself. Let's get this out. Put that on the floor down there. That was a big thump, wasn't it? And here we are. And the most important thing to note about this power supply, other than its ratings, etc., is that this is a modular power supply. Can I get in? Let's get Mr. Scissors in to cut through the tape. There we are. I can get in. As I was saying, this is a modular power supply. So you'll notice that here we've got the power supply and all of the cables we need to use it. Whereas if we look back to the old power supply, you'll see all the cables are permanently connected. Whereas with a modular power supply like this one, you can select just the cables you need to have inside the computer and plug them into the back, where, as you can see, we've got different connectors for different types of power requirement. They're actually the wrong way up if we want to see the labels. There we are, that's a bit easier. You can see we've got outputs here for powering the motherboard, SATA drives, etc. And the other great thing about this power supply, if I flick it round the other way and back over, there's a label at the back that reminds us that this power supply is silent below a certain level of output, which is 220 watts. So the fan doesn't come on when the power supply is outputting less than 220 watts, and it comes on under temperature control beyond that. So a lot of the time, this will be a very, very quiet power supply indeed, and it's therefore a great power supply to choose if you want to build a very quiet PC. So what I'm going to do now is to unpack all of the cables, rustle, and fit just the ones I need into the back of the power supply. So I'll get on with this. And there we are. I don't need these in the computer for now, but of course I'll keep them for later. And I'm sure some people are writing in the comments, Chris, plug these in when the power supply is in the computer. I find it easier to have better access when it's not in the computer. But either way, it's now time to fit this into the computer. So if we go back to the case, we can take the power supply with the fan facing down, so air will come in here and out the back. We'll put it in here. It'll just take a second to get it in and positioned. There we go. And if we put in the screws, there we go, nice and tight. So it's now time to reconnect the octopus. I'm going to put back in motherboard power and drive power first. There we go. And I've left this cable here, which is going to be a flying power lead for SATA devices. This is a test rig, so I like to have a spare cable. It might power this hard drive, it might power other things as I open the case up and do experiments. But I must put in also the 12 volt ATX power connector, which is now an 8-pin connector and goes in down here. And with some semblance of cable management reapplied via the magic of filmmaking, our computer now has a new and hopefully much quieter power supply. Greetings! Here I am back again, and I've now given this rig a quick test and everything worked perfectly, and I discovered that the only thing now making any significant noise in this computer is this, the back case fan. And the case cooling principle in this computer, as in many desktop PCs, is that air enters from the front and exits out the back, and our new Noctua CPU cooler works in the same direction. And the power supply will draw air from the inside of the case and exhaust it out the back when its fan comes on as well. So what I'm now planning to deal with the noise from this back case fan is to replace it and also to fit another case fan here at the front, with my intention being to move the same amount of air through the case but more quietly. And to do this, the fans need to be as big as possible, as the larger the fan, the slower it has to rotate to move the same amount of air. Down here at the front of the case we have mountings in here somewhere for a 120mm fan. We'll look at that in more detail in the next segment of the video. And currently at the back of the case we've got an 80mm fan. But if we look around the other side we can see there are mounting holes for a 92mm fan, which is what we're going to fit. And if you're measuring a case, note that fan mounting centres are 72, 82.5 and 105mm apart for 80, 92 and 120mm fans respectively. Right, here are our new fans, both from Noctua, and they are a 120mm NF-F12 and a 92mm NF-A9. And these cost me £19.99 and £16.99 respectively, and they currently sell for about $21 and $17 in the United States. So these are expensive fans, but if you want to make a really quiet PC, I'm afraid it comes at a cost. And Noctua fans very much are the Rolls-Royce of fans. They are expensive but very quiet. And they're also rather overpackaged. We look at one of these here, you can open up the front and look inside, but like a book, and you can open up the back as well. This really is not entirely necessary. Anyway, let's get these opened up. There we go, and as you can see we've got our fans, we've got various things that come with them, which are in no particular order. This is, I think, an extension cable. This is a noise reduction cable to run the fan at a lower speed. And somewhere here there is a Y cable, there we are, which allows us to run two fans from the same motherboard header. And we've also got various means of mounting these fans. We can mount them with screws down here, or we can mount them with these things, which are little silicon anti-vibration mounts. Although I think I'm probably going to use the screws rather than the silicon anti-vibration mounts. And the final thing to say is I'm going to be putting both of these fans into a single motherboard header. I'm going to be using this Y splitter because I've only got one motherboard header on the motherboard I've got. And if you're going to do this, do check on the ratings. But I know my motherboard can supply up to 2 amps from its 12-volt fan connector socket, so that's plenty to power these two fans. This said, it is not ideal to be powering two different fans of different sizes and different types from the same motherboard header. It'll work, but it may confuse things in terms of speed control and speed monitoring. But we will see. It's what I'm going to try. So let's now fit these in the case, from which, as you can see, I've removed the front panel so we can put in the 120mm fan here. But we'll start with the back case fan, which I first need to unplug from the motherboard down here. There we go. And I'll now remove the fan. There we are. Goodbye, old fan. And we'll put in the new fan, making sure we get the airflow in the right direction. It goes out that way. There we are, all mounted. And I'm now going to take the cable from this fan and plug it into one of the Y adapters. And I've been looking at these very carefully, and it's clear that one of the outputs from Y adapter has got 4 wires going into it and one has got 3. So both outputs carry power and a PWM, a pulse width modulation signal, to control the speed of the fan, but only one has got the extra wire to actually monitor the fan speed, which makes perfect sense. So what I'm going to make sure I do here is to make sure that this fan is the one I'm actually monitoring the speed of. So I'll plug that into what I know is the 4 wire output coming from the Y adapter. And now to get this plugged into the motherboard, which is going to be a nightmare. Let me see if I can do that. Yes, it has gone in. I didn't even attempt to give you a shot of that. And we can now fit the 120mm fan, which has to go in down here. So if we turn to the front of the case, we can see it's got this removable panel. So I'll just take that off. Here we go, and there we are. And the fan should fit, in theory, in here onto this. So I'll get on with fitting the fan. There we go. And as you can see, the fan is there. I've got the airflow in the right direction so it goes into the case. And if I now just thread the wire, including the extension lead, through the front, I can in theory get this thing in. Good Lord, it fits. I shouldn't be surprised, but yes, it's gone in. And we now just put back the screws. And there we are. Our PC's now got two lovely new front and rear case fans, which by the magic of filmmaking are also both now connected. So if I just put the computer all back together, we'll be in a position to run some final tests. Well, here I am back again, and I'm now a very happy bunny indeed, because this PC is now incredibly quiet. As you can see, we're in the BIOS, and in the fan settings here, I've set a silent profile for the chassis fan, the same way I did for the CPU fan in the last video. And if we go back to where we just were in health monitoring, you can see that the CPU fan is going along at about just under 600 revolutions a minute, and the chassis fan, that's the one at the front we're monitoring, is just over 500, and our temperatures for both the system and the CPU are about 25 degrees C. If we hop across to a Windows desktop, here we are where I'm running Open Hardware Monitor as previously, we can see that the CPU package, oh, it almost hit 27 there, but it's still running at about 25, something like that, at idle. And even more significantly, I've got my recorder and sound meter set up again, where, as you can see, the sound meter cannot even register the sound coming out of this computer, which means it's below 30 dB. And if I just pause so you can hear the sound being made by the recorder, well, there we are. It is very, very quiet indeed. A very significant change from when I first monitored the noise made by this computer in the first video in this series, when it was making about 42 dBs of noise at idle, and it sounded, if I just give a pause, like this. Oh, and if you're wondering, I showed you the power use of the PC on a power meter earlier on. It was consuming about 20 watts at idle. It's now consuming no more than 13 watts when we're idling along here in Windows, so this project is being a great success. But of course you want to know what happens when we go up to load, so I'll open up my script for Lightwave ScreamerNet again and run that through and let it run for about half an hour. And here I am back again with the PC having been rendering for about 45 minutes. Its temperature's got up to about 42, sometimes 43 degrees C. That's not bad at all, is it? And if we go across to the power meter, we're now hitting a maximum of about 67 watts compared to about 74 running this test previously. And if we look at the recorders, well, it's still very, very quiet, isn't it? We're still seeing low on the meter almost all of the time. Just occasionally it flicks above that. We get almost above 30 dB and it goes back down again. But the PC is being very quiet indeed. And I'll just pause again to let you hear exactly how much noise is being made. It really is very little, and we'll now compare that to when I ran the rendering load test before we changed any hardware, and it sounded like this. So, returning to the quieter version, I'm very pleased with what's gone on here. These tests show that the PC really is now very quiet, which is great for me for recording purposes. And I'm sure some of you are saying, oh, but it hasn't got a graphics card, and that is true, we're using internal graphics here, although I suspect at some point in time I'll add something like a passively cooled GT 1030, just so I've got a few CUDA cores available for certain projects. Oh, and just before I close, let's set something up. Here we are. Here I've got the recording for any changes were made to the PC at idle, and here I've got the recorder recording, if you see what I mean, after all the changes have been made. If I play the first one, you can see it's that's the level. Of course, it's very difficult to show you exactly what sound levels are like in a video, but hopefully you can see here it's very different. And the other thing I'm going to do is just to amplify this, just so we can give you an idea of how it looks different. I'm going to apply 30 dBs of amplification to each of these waveforms, so that one and also to this one, like that. And that hopefully shows the difference we've made. There is a massive difference in these two waveforms in terms of the loudness. That is the impact of having made these hardware changes to make a quieter PC. So there we are. Having now fitted a new CPU cooler, power supply and case fans, I've finished making my i5 rig less noisy, and I look forward to using it in many forthcoming Explaining Computers videos. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.